Bismillahirrahmanirrahim. Dear students, hope you are fine. Today is Thursday, 25th of June 2020. आज की इस वीडियो में हम एक लिमिट का एक इम्पॉर्टेंट थ्योरम प्रूव करेंगे, which is limit x goes to a x power n minus a power n over x minus a equal to n a n minus 1, and where n is any integer. दरअसल ये जो मैं आज की वीडियो बना रहा हूँ ये एक डिमांड वीडियो है. मेरे एक स्टूडेंट जिनका नाम उमर महमूद है, उन्होंने मुझे व्हाट्सअप किया था कि ये थ्योरम समझाएं, जो कि बुक में ये काफ़ी कॉम्प्लिकेटेड अंदाज में इसको सॉल्व किया गया है, प्रूफ किया गया है. तो उनकी ये डिमांड थी और उमर महमूद साहब की कि इस प्रूफ के ऊपर एक वीडियो बनाएं और वो वीडियो के ज़रिए फिर हम इसको समझ पाएंगे. तो ये जो आज का लेक्चर है, आज का जो वीडियो लेक्चर है, दरअसल ये एक डिमांड आई है एक स्टूडेंट की तरफ से. तो उस डिमांड को पूरे करते हुए मैं ये आज की वीडियो बना रहा हूँ. ओके, तो द क्वेश्चन इज प्रूव दैट लिमिट x गोज टू a x पावर n माइनस a पावर n ओवर x माइनस a इक्वल टू n a n minus 1 where n is any integer. As we know that integer may be both negative, positive or 0, so we shall discuss all the three cases in its proof. Okay, case 1, when n is positive integer, put x equal to a plus h at this x and this x. We put x equal to a plus h. Now when the original limit is x goes to a, when x approaches to a, then a equal to a plus h equal to 0. So when x approaches to a, then h approaches to 0. So this is our new limit, whereas the old limit was, the original limit was x approaches to a, and this is our new limit. Now put the values over here, this is, and put x equal to a plus h, here put h equal to 0. So the original limit becomes limit h goes to 0, a plus h power n minus a power n over a plus h minus a. Put the value, we have put the value of x over there, a से cancel हो गया, we have got this answer. Now this is actually a binomial expression or binomial expansion having power n, where n is positive integer. Now we shall expand it with the help of binomial theorem, which we have studied in our first year class. Okay, using this formula we get a power n minus 1 into h, where in the formula we have b n minus 1 over 2 factorial a n minus 2 into h square plus so on, and the last term is minus a power n. This minus a power n is cancelled with this power a n, and we are left with this quantity. Now taking n common from the numerator, we get this. Taking h common from the numerator, this h is cancelled with this h, and we are left with limit h goes to 0, n minus 1 plus n minus 1 over 2 up to so on. Using the limit we get, जहाँ पे h है वहाँ पे 0 पुट करते हैं, ये 0 आएगा, पूरी टर्म 0 हो जाएगी, and we are left with limit x goes to a n minus 1, and which is our first case. So in the first case we have proved that limit x goes to a x power n minus a power n over x minus a equal to n minus 1. Okay, I hope everything will be clear to you. Now let us come to the second case, which is where n is negative integer, and which is this very important proof. Okay, so if n is negative integer, suppose n equal to minus m. So in this case minus m suppose किया, where m is our positive integer, because if minus into plus, you have minus, negative into positive, you have negative. So basically we have to keep n as negative. So if we put here negative sign, so we have to take this value as positive. That's why we have taken m as a positive integer. Okay. Now put the value in the original limit. जहाँ n है वहाँ माइनस m पुट कर दें और x माइनस a. Now इसको नीचे ले आए. In the denominator power will be positive. Okay, similarly इसको नीचे ले आए, फिर इनका LCM ले लिया. We have taken an LCM, we get this one. Now bring this over the numerator. We have got this. Because 1 over am is constant, so bring it 1 over am outside the limit and then arrange. Take minus sign is common from this quantity. Minus n common लिया, हमारे पास ये आ गया. Okay. Then take minus n, minus common from outside the limit. We get limit s goes to a, xm minus am over x minus a into 1 over xm. 1 over xm should become over here. We have applied limits separately over the two functions. Now since m is a positive integer, very important, m is a positive integer, so this limit is equal to m minus 1, which we have proved in case 1. Okay, just put n equal to m in that formula. So we have already proved that if for positive integer cases this is equal to m minus 1, put this value over there, where in place of x put x equal to a, we get this value, and from here after simplifying we get there. Now bring a power 2m to the numerator, we get this, and after adding the power we reached here minus m, a power minus m minus 1. From here we get this one. लेकिन जहाँ माइनस m है वहाँ हमने n सपोज किया था. जहाँ माइनस m है वहाँ हमने n सपोज किया था, इसलिए यहाँ पे अब आप n पुट कर दें. ओके, इधर n पुट करेंगे तो ये हमारे पास प्रूव हो जाएगा. ओके, so second case is proved, also proved, where your n was basically a negative integer. Okay, now let us come to our third and final proof, which is case 3, where n is equal to 0. Okay, now n equal to 0, put in the given limit, we get limit s goes to 0, x power 0 minus a power 0, this is equal to, this is our actually left hand limit, left hand side, this is our left hand side, and its value is equal to 0. Now right hand side was n minus 1, put n equal to 0, we will get again 0. So if n equal to 0, left hand side equal to right hand side, so in this case we also prove that limit s goes to a, n minus 1. Okay, so we have proved that whether n is negative integer or positive integer or even 0, our formula limit x goes to a, x power n minus a power n over x minus a is equal to n minus 1. Okay, so this was our today's lecture. I hope and trust that all the concepts involved in this proof will be clear. If you have got any difficulty, if you have got any problem, any issue regarding this proof, please contact me on Google Classroom module, or even contact me with my WhatsApp number, which is 0308 5109 372. Okay, this is all from me. Goodbye students. God bless you. Thank you very much.